Aldol condensation, a very important phenomena that is shown by aldehydes and ketones which have alpha hydrogen. Greetings to all in Dr. Abha Chemistry Pathshala. So here we are going to talk about this important phenomena of aldehydes and ketones. It is of two types: self-aldol, where the condensation takes place on the same aldehyde or ketone, and there's cross-aldol, where any aldehyde or ketone reacts with any other aldehyde or ketone to give beta hydroxy aldehydes or ketones. Needless to say that when we talk about cross-aldol condensation, the condensation can take place on aldehydes or ketones which do not have alpha hydrogen with the help of the ones which have alpha hydrogen. So to know more about the condensation, let us quickly jump onto the screen. The topics for the video are Aldol reaction, Aldol condensation, difference between Aldol reaction and condensation, difference between self-aldol and cross-aldol, and the last we will be doing the mechanism of the reaction. Let's get started. Aldol condensation. Here we take aldehydes having alpha hydrogen. They react with itself in presence of dilute NaOH to give beta hydroxy aldehyde. Now here we have to see that the same, whatever aldehyde we have taken, the same aldehyde we have written here because it's a kind of the reaction happening as self-aldol, it's happening with itself. Now if you can see, this is aldehyde, this is alpha and this is beta. So we get beta hydroxy aldehyde and this is nothing but aldol. This can take place in ketone as well. The main difference between aldol reaction and the aldol condensation is, in condensation, the beta hydroxy aldehyde which we get after the aldol reaction, that undergoes elimination. It undergoes elimination of water. As you can see that here water comes out to give us alpha beta unsaturated aldehyde or ketone. So at the last what we get is alpha beta unsaturated aldehydes. This is the product after condensation, and after aldol reaction we only get beta hydroxy aldehyde. Let us do the difference between self-aldol and cross-aldol. Self-aldol, as the name suggests, it will take place for two molecules of aldehyde and ketones. That is, the same aldehyde and ketone will react with itself. The only thing which is required is that alpha hydrogen has to be there. So the ketones in presence of alkali will give beta hydroxy ketone, which will undergo elimination to give alpha beta unsaturated ketone. I have taken example of a ketone that is having alpha hydrogen. I could have taken an aldehyde also with alpha hydrogen, but in self the same molecule will react, same molecule reacts with itself. Same molecule reacts with itself. So that has to be taken care of. It can be an aldehyde or it can be a ketone. Cross-aldol, we have two types. In the first type, we can take two different aldehydes or ketone, both having alpha hydrogen. Here we get four products. Now how we get four products is, so the first will be the self product of aldehyde. So suppose we want to show cross-aldol between aldehyde and a ketone, and both are having alpha hydrogen. You can see we have 3 alpha hydrogen here and we have got 6 alpha hydrogen here. So both of them are reacting to give cross products. Now in this cross we will have 4 products. The first one will be the self product of aldehyde. So here we take an aldehyde, here we have another aldehyde, it will give beta hydroxy aldehyde. Now in beta hydroxy what we have to do, we just have to take this OH, and this H will get attached with the O and this left part will get attached with the C, right? Once again, this alpha hydrogen that is attached to the carbonyl oxygen, and whatever is the left part that gets attached to the carbon. So if we get beta hydroxy aldehyde, and for condensation what we'll do, we will eliminate water to give us again the alpha beta unsaturated. In this case we get aldehyde because we are writing the self product of aldehyde. Since the reaction is between aldehyde and ketone, we will get the self product of ketone also. We have already done this. So this is one ketone, this is the other ketone, and this is the alpha hydrogen. This alpha hydrogen definitely will get attached on this oxygen, and this part will get attached on the carbon. So this is the, we get beta hydroxy ketone, and this beta hydroxy ketone undergoes dehydration to give, this is alpha beta unsaturated ketone. Other than these two self products, we get two additional. For the cross product of ketone and aldehyde, first what we do is alpha hydrogen are given by aldehyde. So when alpha hydrogen are given by aldehyde, the product what you get will be an aldehyde only, because this functional group is not getting disturbed. But yes, the reaction is taking over this functional group, that is the ketone. So first case mein you will get an aldehyde, right? So because the reaction is on the carbonyl of ketone, so you get beta hydroxy aldehyde. And if you have to write the aldol products, you will get alpha beta unsaturated aldehyde. For cross product of ketone and aldehyde, the second one is now the alpha hydrogen is given by the ketone, unlike the previous one where the alpha hydrogen was given by the aldehyde. Now this alpha hydrogen will attack on the carbonyl oxygen to give us beta hydroxy ketone. Because the alpha hydrogen has been given by ketone, the ketone functional group will remain intact. And after that usual elimination of water, this OH will go, and that there is the next hydrogen, whichever is the next hydrogen, that is the alpha to the carbonyl group, that will give alpha beta unsaturated products, and in this case it is going to be a ketone. So mind it, we get 4 products. We get 4 products, 2 will be the self products, 2 self products and 2 cross products. And in both the cross products, please note the species which is giving, the species which is providing with the alpha, that functional group will remain. Okay, let's do the second case of cross aldol. Here we can take 2 different aldehyde and ketone and only one has alpha hydrogen, not both. Okay, here we get only 2 products, like if we take ketone which has alpha hydrogen, right, and we take an aldehyde benzaldehyde without alpha hydrogen. If you know, if I draw structure of benzaldehyde, so this is benzaldehyde, this alpha carbon has no hydrogen, so this has got no alpha hydrogen. So here first we get the usual self product. If you can see for this ketone, this is going to be the aldol product and this is going to be the condensation product, that is this is going to be the alpha beta unsaturated ketone, because after the removal of water. Now for the cross aldol between ketone which gives the alpha hydrogen, we will have this ketone whose alpha hydrogen will be given. So this will remove as one part and this will go as the second part. So H gets connected over the this, and this CH2 gets connected to the this H, and we get, this is your ketone and this is the alpha and this is the beta. So this is beta hydroxy ketone and this is alpha beta unsaturated ketone, right? For writing the mechanism, the step 1 will have this OH coming from the base, and this OH, it helps in abstraction of proton. This is acidic proton. Why this is acidic? Because of this conjugation. There is a carbonyl oxygen. Because of this conjugation, this H is easy to break, it forms H2O and you are left with enolate, because there is a double bond also, right? This enolate attacks on the carbonyl carbon. So this is the enolate which was produced in the first step with the help of base. Negative charge of the enolate that attacks the carbonyl carbon, just like in nucleophilic addition, the way you saw the nucleophile attacking the carbon, same thing here is happening, and you get anion, right? Now this anion again attacks water. The negative part attacks water to give beta hydroxyaldehyde. OH gets removed. Now this is your aldol reaction product. If you want, you can perform alpha beta, you can perform dehydration. This water is removed to give you alpha beta and such. So we meet next in another topic of aldehyde and ketone. Till then, take care of yourselves. Bye bye.